Hello everyone, hope you guys are doing well. In this video I will be talking about activity series. About the activity series, what do we know? The given table shows us that as we go up, oxidation increases. You become better at oxidation, okay? Also, as we go up, the activity increases, like you become more reactive. And as we go up, because your oxidation is increases, you become also good at reducing agent, as we know from previous videos. If there's oxidation happens to you, then you're a good reducing agent. Now, what kind of examples will be given? For example, if do you remember in our lab we had a zinc metal, like in a beaker, the small round zinc metal, and then we threw it into the blue solution of copper nitrate. It was like ocean blue, if you guys remember. And let's say we didn't do it in the lab, and then we want to see whether this reaction will happen or not. As you guys can see, the zinc is located higher than copper, okay? So because zinc is more reactive, zinc is gonna kick out copper. Zinc is gonna kick out copper, and then copper is gonna be left out. So what happened over here? Let's observe. Zinc went from here to here, and then copper went from here to here. If we observe, what's the charge of copper here? Copper in this case, because this is a nitrate ion, this nitrate ion holds a charge of -1, right? So if we write this guy, copper nitrate, in here, this is -1 and this is x, right? So 1 times x plus 2 times -1 equals to 0, because this whole thing is 0, right? And then x minus 2 is 0, x is plus 2. If you do the same thing to this guy, you will see that zinc is also plus 2. Okay, so zinc is plus 2 here, copper is plus 2 here. So if you look at this, let's write this down in terms of just metal, because that's where the single replacement happened. See, single replacement from your 10th grade. Zinc replaced its place with copper. So zinc plus, what's the charge of copper? Let's just write the ions copper plus 2. And then if we go here, we write the zinc with charge of plus 2. And then we write the copper. You see, we understood that this reaction, because zinc is more reactive, this reaction is spontaneous. Spontaneous reaction. That means that it will occur, okay? And even in the lab, we observed it. We observed this as well, because we saw that the metal got covered with dark color. We understood that copper, which is solid state, when you have a 0 charge, it just went to the surface of the zinc metal that we had in the beginning over here. And then let's do another one. If I would dip copper inside zinc nitrate solution, do you remember this was colorless solution? We had that in our table. And then copper, we didn't have it in the lab, but it's like a brownish metal. If I dip this brownish metal into zinc nitrate solution, I want to know if this reaction will occur or not. If you guys observe this, you will see that up in this table, copper is below than zinc. So copper cannot kick out zinc. So this reaction is not going to happen. That's why it is non-spontaneous. Okay? And if you write this in terms of ions, what's the charge of this zinc in here? Because this is -1, as we did it here, this is going to be plus 2, right? And then copper by itself is 0. So copper 0 plus zinc 2 is not gonna happen. But as you can see here, zinc by itself is 0, zinc 0 plus copper 2 will give you the product of zinc 2 plus and copper. This is spontaneous. And then this is non-spontaneous. Okay, I think it should do good for you guys. Now I'm gonna move on to a couple of exercises about this. So for example, over here it's asking the table below shows partial field reactivity series. Which of the following elements could be X? So we look at this, we see that iron is here and silver is here. Okay, so this element needs to be below iron and then above silver. If you look at the table, you will see that lithium is up high, gold is below, silver, carbon is not there even, and then copper is the metal. Is the metal that just sits right here. Okay, that's the answer A. And then we're gonna look at this ones. For example, I don't want you to guys write down what are the products. I want you to tell me whether this reaction is spontaneous or non-spontaneous. Non-spontaneous means that it won't occur. As we know, Ag is here is 0. I'm just going to do without the charges. So Ag reacting with potassium, right? We know that potassium sitting is higher than silver. Silver cannot kick out potassium. That's why this reaction is not going to occur. Okay? And then we'll look at zinc and silver. We know that because zinc is higher than silver, zinc is gonna kick out potassium. And if you really want to write down the products, so it's gonna be zinc NO3 plus 2, and then you got silver out. Okay? But we don't ask you to do this. Okay? Don't worry about this. Products. All we're gonna ask you to write us the products. For example, let's check this aluminium reacting with H2SO4. So we want aluminium to kick out hydrogen, right? To kick out hydrogen and give us this product. As I said, you don't need to write this, but if you kick this out, the only thing you need to do, you need to check whether aluminium is located higher than hydrogen. And now if we go back to the table, we will see that aluminum is actually higher than hydrogen. So this reaction is gonna happen. So it is spontaneous. Okay, so you're gonna do the same thing all over here. And there's one more thing regarding this bromine plus calcium ion. So do you remember, beside the activity series, we need to know that fluorine, chlorine, bromine, and iodine. The electronegativity increases as we go up. You need to know and memorize this by heart. Among them, the same thing happens here. Reactivity increases as well. So fluorine is the most reactive, iodine is the least reactive. Now let's pay attention over here. So bromine and calcium ion, right? Iodine is below than bromine. Because bromine is more reactive, bromine is going to kick out iodine, and then it's going to make calcium bromate ion, and then iodine will be out. Okay? And then let's check out this guy, the P. So chlorine and magnesium iodine. Because chlorine, as you guys see, is higher than iodine, chlorine is gonna kick out iodine out, and then it's gonna be magnesium chloride plus iodine again. This is a spontaneous reaction. And then let's do this one. Magnesium is trying to kick out hydrogen. And then we're gonna check the table. So we'll see, where's the magnesium? Magnesium, you see, is sitting higher than hydrogen. So magnesium is gonna kick out hydrogen. So magnesium kicks out this guy, comes hydrogen. You don't need to write the products. All you need to do is tell me whether this reaction will go. And we know that magnesium will kick out hydrogen, that's why it is spontaneous. Okay, that's all you need to know about the activity series. Now let's do this table together with you guys. This is about, like we have magnesium. We want to know if magnesium will kick out iron, okay? And if reaction goes, we put tick mark. If reaction doesn't go, we're gonna go cross, okay? So now let's check this out. Magnesium and iron. Let's go to the table. Where is the magnesium? Magnesium is right here. Where is the iron? Iron below. So magnesium is actually reactive than iron. So magnesium is gonna replace iron, kick him out. So this reaction happens, okay? And then we're gonna look like metal with itself, this and this does not react. Magnesium is the same with magnesium, so they're not gonna replace anybody. Let's check out iron with copper. So iron and copper. Let's check out iron, and then we have iron in here, okay? And then if I go down, iron is higher than copper, right? I forgot to check the copper. So iron is higher than copper, so iron is going to kick out the copper, so this reaction occurs as well. Okay, now let's do this exercise. We did it in class, but I want you to do it together. So XNO3, so we know that Y couldn't kick out X, that's why X is more reactive than Y. Over here we know that Z kicked out Y, that's why we made this change, so Z is more reactive than Y. And then Z kicked out X, that's why we have this product, so Z is higher than X2, okay? Now if we check them out together, we know that Z is higher than anyone. Also, now we need to look which one is higher, X. So we got X, and the least reactive is Y. Okay, this is the order that we have. And then you can use this ones to do you can check the answers. I have attached the answer sheet for this worksheet. And that's about it for activity series. Hello everyone, hope you guys are doing well. This is the last part of the video about voltaic and electrolytic cell. So in chemistry we said that the cell is not the cell as in biology, but this is a battery cell, or the voltaic and electrolytic cells that we have. This has to do with electricity. So voltaic cells are the ones that we use for spontaneous reaction. If we have a spontaneous reaction, we can put two electrodes. Electrodes are called these metals. We can dip them inside our voltaic cell and we will get electricity. I'm going to show you how it happens. But before we move ahead, I just wanted to review a couple of things. So copper and silver as a metal. Because we know that copper is higher than silver on the activity series, we know that copper is more reactive. More reactive, oxidizes better, and a stronger reducing agent. Okay, so now what do we have? If you guys remember, we had this copper nitrate solution. So copper nitrate solution was a blue, ocean blue solution, and this copper nitrate solution, because it is dissolved in water, it made two ions, copper 2 and nitrate ion. Okay, they are all aqueous solution. And as you can see, we have like many copper 2 pluses in here, and then lots of nitrate ions in here. They're going all over the place. Okay, so what we did, we had this copper electrode and we dipped this metal inside this copper solution. Okay, and then on this side I had another solution of silver nitrate. This is a little lighter blue, and silver nitrate, it's another salt. if we dissolve it inside the water, which they did on this picture, you will get two ions, silver +1, NO3 -1. Using the ionic table, you can actually know what are the charges of these ions. To be honest, in your case, you don't really need it. All you need to know that we have two ions in here. So this one is Ag+, like many millions of them are inside this solution. Okay? And we dipped inside this silver electrode inside. Okay, so as you guys know, I can have two reactions here. One is going to be copper plus Ag plus, or Ag plus copper 2. Okay, either of the two, because it's got to be redox. And as we know that because copper is higher than silver, copper is going to reduce silver. Copper is going to become like this and make this reaction go like this way. But this reaction is not going to work. It is not spontaneous. Or if you want to write it in terms of salt, copper plus silver nitrate gives you the product of copper nitrate and then silver. But this reaction of silver plus copper nitrate is not going to happen. Okay? So using this reaction up here, or this reaction, let's write down our half reaction. So for oxidation, we know that copper went from copper 0 to copper +2. So copper 0 and then copper +2. So in order to balance, we add 2 electrons on this side, so both sides is going to add up to 0. Okay? And then reduction is what? We have silver +1, and then gives us silver on this side. If we do charge balance, we need to add 1 electron here, because this is +1, add -1 will give you 0 on both sides. Okay, so this is reduction, this is oxidation. Okay, so we know that that's what happens on this side. So copper going to copper +2, and on this side of the reaction, we know that it is Ag going to silver 0. Okay, so as we know, the copper 2 was in dissolved form in here, right? Copper +2 ion. While copper itself, when it's 0, it is a metal. Because copper went from 0 to +2 charge, we know that some of this metal eroded and fell into the solution. Now the same thing goes many times in here, and we have bunch of copper +2 ions collected in here, because this is spontaneous reaction, right? And on this side, because silver plus ion was before dissolved in solution, now because it's going from silver plus to silver 0, then it's coming to here and attaching to this wall in here, and then as you know over here, it takes electron and then becomes silver. So it sits on top and makes like Ag solid form, okay, in 0 charge. We have lots of silver sitting on it, so this electrode becomes heavier. And how this reaction happens? So we said that copper +2, right, in order to balance, we give 2 out, 2 electrons. So in oxidation reaction, we lost 2 electrons. How did it happen? So you see the copper with 0 charge, with 0 charge, when it eroded, copper +2 went into the solution and 2 electrons went up. Okay, so electrons going up, and as you can see, going through the wire and lighting this light bulb. And then electron passes through here, comes into this electrode. Okay, and then from here electron comes in here, and this silver plus ion, when it comes and approaches this guy, electron and silver bind together and make silver 0, as in our reduction reaction. So So it made silver 0, and we know that when it's silver 0, it's solid. The same thing with copper. When it's 0, it is solid. Okay? But there's one thing. Do you remember we said that we had many nitrate negative ions in here too? So all of this silver comes and binds to this 4, and all of this silver plus ion starting to become less and less and less. Now we have lots of nitrate ions collected in here, so this guy become negatively charged, while this guy, because we have lots of copper 2 ions collected on the left solution, so we have many of them because of the oxidation, this become positively charged. But as we told before, you see the electron was going through here, right? But now when you have a positively charged solution, electron cannot go, because we know that positive and negative attract each other. They want to come together, okay? But negative and negative, they want to leave each other. Because electron is negatively charged, now electron doesn't want to leave, so it kind of stops in here, and our light now is gonna turn off. Okay, so how can we balance this? The way we can do is that if we have a salt bridge is another solution. So this is over here, we have sodium nitrate. So let's say I had sodium nitrate. This is a salt. Another one is like sodium chloride, the table salt we have at home. We dissolved it inside the water. We dissolve both. The product we have is sodium nitrate is going to be in ionized form. They are both aqueous solution. So the same thing with sodium plus aqueous solution. When we dissolve our salt inside the water, all of the salt dissolves and we don't see anything. It becomes colorless. But we have lots of ions in it. Okay, sodium plus, chlorine minus, same thing with sodium and nitrate ion. Okay, and we pour this inside a tube, U-tube. It's not the U-tube that you watch, but it's a U-tube for our lab. Okay, so we have lots of sodium ion, nitrate ions inside this guy. Okay, and we put the current ending in here, so only ions can pass through it. Like sodium can go in and out, or nitrate can go in and out, but the water is going to stay inside. Okay, now when you have a positively charged solution, the nitrate ion is going to fly to here to balance this and neutralize the solution. Okay, neutralize the solution. While when you have a negatively charged solution in here, because of the nitrate ions, the positively charged ion is going to come through here to balance this. Okay, so this way we're going to have the electricity again turning on, because electrons no longer are attracted to positively charged solution, so they're going to leave the solution again and then make the light turned on. But there's one thing, we need to know which one is anode, which one is cathode. So there are two electrodes. Because we said that copper oxidizes and silver reduces, right? Because it takes an electron. There's one easy way to memorize this: anox and the red cat. So anox stands for anode, is where oxidation happens. Okay, reduction happens at cathode. Okay, so one of them is anode, one of them is cathode. So anode is the oxidation. So because copper oxidized, this is anode, and because silver reduced, this is cathode. And we need to know the charge. Okay, because copper, you see, copper in here, copper oxidized, it lost the electron. This electron went up here, went through here, and electron left. electron is negatively charged. We said that if both things are negative, they repel each other, they move away from each other. Because this anode is negatively charged, electron leaves this electrode. Is it clear? And moves on here. And because this guy is positively charged electrode, meaning that cathode, positively charged electrode, electron is moving towards him because negative and positive are attracting each other. Okay, so as a summary, if we write it down, voltaic cell, anode is negatively charged and cathode is positively, negative and positively, cathode is positively charged. You need to know this, and we know that anode is where oxidation happens and cathode is where the reduction happens. Okay, so now we're going to move into electrolytic cells. So electrolytic cells are meant for non-spontaneous reaction. So for example, if the reaction does not go, we can put inside energy, and make this reaction go. While in voltaic cell, it was happening by itself, so it was providing us energy. But this time, we're using battery to make the reaction go. The example is this. So for example, if you have sodium chloride at home, the table salt in your kitchen, you leave it for years, nothing is going to happen to it. It's going to stay as sodium chloride. But if you melt this sodium chloride, and then put in electricity through it, you will get sodium and chloride gas. Okay? Because this reaction doesn't happen by itself, we know that it is non-spontaneous. And we use electrolytic cell in order to make this non-spontaneous reaction happen. Okay, the chlorine is coming out as gas. So let's write this one in here. So sodium chloride. First of all, you need to understand that sodium chloride was given as solid, and then we melted it down. When you melt it down, it becomes liquid, right? And when it becomes liquid, it makes two ions, sodium and then chlorine minus ion, when it's in a liquid form, the table salt. Okay, and then we insert two electrodes. In here, it's the same electrodes, same both metals on both sides. Okay, so both metals, you insert this inside this melted solution. Over here, we want to know what is happening. Let's write the half reaction. Before we move on with half reaction, we need to write down our oxidation numbers. So chlorine in here is -1. I told you the halogens, fluorine, chlorine, bromine, iodine, they're all -1, and sodium is +1. Because it's a +1 first group element. And sodium in here is 0 by itself, chlorine is 0 by itself. So if you write this sodium +1 goes into sodium, you need to add 1 electron in here. So this is reduced, and then oxidation is happening with chlorine, where you have chlorine minus here going and giving us chlorine 0. So if you add 1 electron here where we got lost, this is where the oxidation happens. Okay, so we had chlorine ion and positive sodium ion in here in liquid form because it's melted, right? Because chlorine got reduced, it went to this electrode and started coming and attaching through here, and it gave away. Do you see, like, it lost the electron, right? The electron is lost. Chlorine comes, the negative chlorine minus ion comes and attaches to this electrode and gives out its electrode to here. Okay, it attaches to this electrode. This is called anode because we said that anode is where the oxidation happens. So this guy is anode, where anode, and this is cathode, where red cat. Okay, red cat, anox is where the oxidation happens. So chlorine minus, where the oxidation happens, comes and attaches to this inert electrode. Inert means that it does not react. The metal, nothing happens to metal. Okay, so this metal comes, this chlorine minus ion that is melted starts attaching to this metal in here and gives out the electron. Electron flows through the metal, it comes upstairs, and then goes to the battery. So we need to first of all figure out what's the charge of this side of the battery. We know that the battery has plus and negative side. Because electron is moving towards it and electron is negatively charged, it's going to be plus side of battery, and we have negative side of battery. And then from here, from the negative, electron comes out. Okay, negative and negative repel each other. Electron comes out, comes to this electrode. Electron is here now, and look at this. The sodium ion that is dissolved comes and attached to this guy, okay, and absorbs this electron, gains electron. You remember, oil rig part, reduction is gaining. So this is where the reduction is happening. Sodium plus ion takes the electron and becomes sodium 0, which is a solid form of sodium. So sodium starts attaching to the wall of this inert metal. It does not react with the metal, it just sticks to the wall. Okay, so because this is a reduction happening on this electrode, we call it cathode. Okay, and electron is came to this guy to cathode. Okay, and then this is where the whole thing happened. As you guys can see over here, the chlorine ion approaches this electrode. We know that this is chlorine is negatively charged. It will come to the electrode which is positively charged. And we know that the chlorine oxidized in here, so it makes anode positively charged. Okay. While in here we have sodium is coming to cathode, where the reduction happens. Because sodium is a plus, carries plus charge, it will come to electrode which is negatively charged. Is it clear? So that's why it is negatively charged. So from here we know that in electrolytic cell, cathode is negatively charged. Anode is positively charged. While if you look back in voltaic cell, anode is negatively charged and cathode is positively charged. They are just opposite of each other. You just need to know this. Okay guys, we'll quickly go through these questions here too. So it's asking which of this is true statement about voltaic cells. We said that voltaic cells are spontaneous. So they have the chemical energy spontaneously coming out. It naturally occurs and we turn on the light. Do you remember? We in our light bulb. So we got the electrical energy coming out of it. So that's why the answer is A. It's saying as what's the main difference between voltaic and electrolytic cells? As we said, because voltaic cells are for spontaneous ones, they convert chemical into electrical, and electrolytic cells convert electrical energy. We remember we had the battery giving energy inside the solution, and we would get the chemical energy out of it. Okay, so that's why the answer is B on this one. Is here is asking following reaction. List the species being oxidized. As soon as you see this question, you go put your oxidation numbers. We got 0 and 0 here. We got -1 and -1. So we know that fluorine went from 0 to -1. It got reduced. So fluorine got reduced. Iodine went from -1 to 0, so it got oxidized. Okay, if we write the half reaction, you would do like this, and iodine 0, you would leave out 1 electron. And then reduction is fluorine went from 0 to fluorine. -1, it received 1 electron. So gained electron, lost electron. It says which species receives electron from anode. It's a trick question. It's just asking which species receives electron. So you know that receives electron. Who received? Fluorine, right? It's asking about anode. We know that the anode is this guy, and this one is cathode, right? Cathode, red cat. Cathode happens, at cathode we have reduction, at anode we have oxidation. So it's saying which species receive electron from anode. Anode, you see, donated electron to cathode. And who took it? Fluorine. And which species donates electron to cathode? So donated electron to cathode, you see electron is here. Who donated it? This iodine minus. Give out the electron. Okay. And then we go. A voltaic cell is constructed using electrodes based on the following half reactions. So we have voltaic cell. As soon as you see this reaction, you need to check copper and manganese, their activity. We'll go up in here. We'll see where the magnesium and copper are located. We see magnesium is higher than copper. Okay, so we're going to go back into our question where manganese and copper. So because magnesium, is located higher than copper, magnesium is gonna oxidize. Okay, magnesium is gonna oxidize while copper is gonna reduce. Copper 2 plus 2 electron, take 2 electron is reduced. Okay, which is the anode, which is the cathode? Because we know that magnesium is higher than copper, magnesium oxidizes. Oxidization happens at anode, and this is cathode because that's where the reduction happens. Red cat, anox. We go to question 11. So we have here, watch out for this question. This is a very important one. So this is voltaic cell. This is shown with V, and then we have zinc nitrate solution and copper nitrate. If you remember, we had this in the lab. This was colorless. This was blue, ocean blue solution. And we have copper electrode and zinc electrode. We know that from activity series, zinc is located higher than copper. So zinc is gonna oxidize and copper is gonna reduce. Copper is gonna reduce from our half reaction. If we want to write the whole reaction, zinc plus this side, copper is copper 2 given out, zinc 2 is copper. Okay, we're gonna just ask you to write down the half reactions. Okay, now it's asking about is galvanic cell. Galvanic cell or voltaic cell, they're the same. Label the following: direction of electron flow. So we know that this is zinc electrode. So zinc reduced, right? Zinc got oxidized. Zinc got oxidized. When you oxidize, you fall into this solution. We know that the zinc nitrate, we have lots of zinc plus 2 and nitrate minus, right? So a piece of zinc from here eroded and fell into here, into this solution. We had this solution, aqueous solution, and we have electron. So 2 electrons went up through here. So electrons went up through here. So we denote the electron direction. So if we had a bulb, it will light up in here, right? Electron will leave which kind of electron? What charged electrode? Negative charged electrode. And because oxidation happens here at zinc electrode, this is called anode. Okay, so it's asking direction of electron flow. we said that it goes from zinc to copper electrode to copper electrode. This is the answer for A. Anode is zinc electrode. Cathode is going to be copper electrode, because as you see, reduction happens at cathode. So this is cathode. We write cathode. Direction of anion movement. Okay, we know that we have a salt bridge in here, right? We have potassium plus and nitrate minus ion inside this salt bridge. Because this guy loses all the zinc into the solution, we have lots of zinc plus 2. So this guy is positively charged, while in here we had copper 2 ions in here and nitrate ions in previous solution. You see, all of this copper comes and attaches to this one because it reduces. See, like it goes from aqueous solution, takes 2 electrons and become copper in a solid form. So it attaches to this, attaches to this. So we got left with lots of nitrate minus ions, so this is negatively charged. So salt bridge, in order to balance this, nitrate ions inside this salt bridge comes out here, okay? And then potassium ion comes out here because positive comes to negative and then negative comes to positive. So that's how they neutralize, okay? So direction of anion movement, anion is the negatively charged. So this guy comes in here into this zinc nitrate solution. Zinc nitrate solution. Okay, now we move on to this question. The figure depicts a voltaic cell. Okay, we have copper, silver. This is the one that we had. Which of the following is not the purpose of the salt bridge? Keep the liquid levels the same. Provide ions that balance charges lost and gained during electrochemical reactions. Keep the solution separated. Complete the circuit. So in here we know that this becomes positively charged and this guy becomes negatively charged. And we put the salt bridge in so electrons could travel from here, from this solution up, right? Otherwise, this positively charged is not going to let the electrons go. So we need this for providing ions that balance the charges lost or gained during the electrochemical reactions. Question 13, it's asking electrolytes conduct electric current. So electrolytes conduct electric current by the movement of electrons from anode to cathode, from cathode to anode, and then by the movement of atoms. Now let's look at electrolytic cell. Electrolytic cell is the one that we had in here. So as you can see, we have anode where chlorine traveled in here and then gave its electron to this guy. So it went from anode to cathode, okay? And anode is positively charged and cathode is negatively charged. It's exact opposite in galvanic cell. So electron always comes out from anode because that's where oxidation happens. You lose electron at oxidation. That's why anode, it leaves from anode, goes to cathode. Okay, now we're going to go back to our question, which is here. So it's the 13 is going to be movement from anode to cathode. Okay, and then when the salt bridge is removed from a cell, its voltage will decrease to 0. Do you remember why? We said that the one of the fluid is going to be positively charged, one of two is going to be negatively charged, and when the electron wants to move this direction, is not going to be able to leave. That's why the lights is going to be turned off. Okay, no light. Sorry for the drawing, but there's going to be no light. That's why the voltage is going to decrease to 0. 15. Which of the following statement is true for an electrolytic cell? If you go through here, migration of ions along with oxidation reaction at cathode and reduction reaction at anode. We know that reduction happens at cathode. Okay, So this is not right. Electrons flow from cathode to anode. We said that it goes from anode to cathode. Electrons form from cathode to anode. Again, migration of ions along with oxidation reaction. Reaction at anode, reduction reaction at cathode. Red cat anox. Sorry again. So the answer is D. A, B, C are wrong. 16. In an electrolytic cell, electrons flow from anode to cathode through external supply, cathode to anode through an internal supply. We know that in an electrolytic cell, it flows from anode to cathode. Okay, but how it happens? Through internal or external? We said that we use battery, so it is an external supply. So 16 is A. And then we got in an electrolytic cell, the electrode at which the electrons enter solution is called electrolytic cell. The electrode at which electrons enter the solution is called what? We have anode, cathode, and the chemical change that occurs at this electrode is called which one? So we need to know electrons enter the solution. Electron enter the solution from where? We know that it happens through